If you were to list the great wonders of the world, you'd probably say stuff like the pyramids, the Great Wall of China, or that one really big ball of twine in Kansas. But what if I told you the most incredible wonder is sitting in your pocket, on your desk, or strapped to your wrist right now, silently judging your search history? I'm talking about code. Yeah, that scary block of text that looks like a cat walked across a keyboard. Samuel Arbesman, in his book The Magic of Code, argues that this digital gibberish is our generation's portal to understanding, well, everything. It's the language we use to simulate galaxies, predict climate change, and most importantly, figure out the optimal delivery route for your late-night pizza. It wasn't always so practical. Back in the day, computers were straight-up magic shows. Take the Mechanical Turk from 1770. It was this creepy-looking mannequin in a turban that could beat aristocrats at chess. People freaked out. Was it ghosts, witchcraft? A tiny chess-loving dude hiding in the box? Spoiler, it was the tiny dude. But for a moment, it was pure wonder. A machine that could think. That sense of wonder, of pure, unadulterated, what the hell is this thing? Was the soul of early computing. You had pioneers like Ada Lovelace and Charles Babbage dreaming up machines that could weave algebraic patterns. You had rogue hackers like Steve Wozniak in his garage, basically gluing spare parts together with dreams and a soldering iron just for the sheer joy of it. Then, the beige cubicle happened. The magic got buried under corporate jargon, IT support tickets, and TPS reports. The playful wizard casting spells was replaced by a guy named Gary, who has to follow a 300-page protocol manual just to reset your password. The enchantment got disenchanted. The magic trick was explained, and now it's just work. But here's the secret. The magic is still there. You just have to learn to see it. Most people look at code the way folks in the 1600s looked at mountains, as hideous, terrifying warts on the face of the planet. Seriously, people used to ask to be blindfolded when crossing the Alps. It took a bunch of poets to convince everyone they were beautiful, so let me be your slightly less poetic guide to the sublime beauty of code. At its core, all code is built on a simple, beautiful idea from a 19th century dude named George Boole. His big brainwave was that you could do math with logic. Statements could be either true or false, like, I am wearing pants, true. My coffee has enough caffeine. Almost always false. You can combine these. It is raining, and I have an umbrella. If both are true, the whole thing is true. If not, you're getting wet. Every single thing your computer does, from rendering a photorealistic dragon in a video game to accidentally opening your front-facing camera, is just billions of these tiny true-false questions being answered at lightning speed. It's a waterfall of yes or no decisions. But programmers don't write in ones and zeros. That would be like trying to build a house by talking to each individual atom. Instead, they use programming languages, which are then translated by a magical thing called a compiler. The compiler is like the world's most patient, literal-minded translator. It takes the programmer's poetic instructions, like repeat this 100 times, and turns it into the brute force binary grunts the processor understands. It's the ultimate middle manager, and for once, it's actually doing all the hard work. This process of building on top of other people's work is called abstraction, and it's what lets us build cathedrals of code without having to reinvent the brick every single time. And this gets really wild when you add in something called open source software. Imagine a global potluck, but for code. Everyone brings their best digital dishes. A little function here, a slick algorithm there, and throws it into a massive public library for anyone to use, for free. That's how things like Linux were built. The operating system that probably runs your phone, your smart fridge, and the entire internet. It's a beautiful, chaotic act of collaboration, like thousands of strangers successfully assembling the world's most complicated piece of IKEA furniture without a single Allen key being thrown in anger. It's a digital tradition passed down and improved upon, like an ancient myth that gets a new software update every few years. Speaking of traditions, we have a little tradition here where we ask you to contribute to our own collaborative project. We don't need you to write any code, just execute a simple command. Find the subscribe button and set its value to true. It's a simple, conditional statement. If this video is awesome, then hit subscribe. Don't leave us with a null pointer exception. We'll be forced to debug for weeks. Okay, so code can be logical and collaborative, but can it be beautiful? Remember those old screensavers? The flying toasters? The hypnotic maze? That weird star field? Back when monitors were basically giant radiation guns, these little animations stopped images from burning into the screen forever. They were a solution to a technical problem, but they were also our first glimpse of algorithmic art. That spark has since exploded into a whole field called creative coding. Using tools like processing, artists and designers are now painting with algorithms. They can simulate the gentle drift of snowflakes, the chaotic flicker of a flame, or generate entire virtual cities out of thin air. It's where the rigid rules of math get a little tipsy and start making art. A big star of this scene is the fractal. That's a pattern that repeats itself at every scale. Think of a tree branch, which looks like a tiny version of the whole tree, or a coastline on a map. Zoom in and you see more jagged little coastlines. Using a few simple repeating rules, a concept called recursion, a programmer can write a few lines of code and generate an infinitely complex fern, or a forest, or the entire landscape of a video game like Minecraft. It's procedural generation, which is a fancy way of saying the universe is built on a copy-paste function. If binary is the one true language of all computers, then we've done a very human thing and created our own Tower of Babel on top of it. There are hundreds of programming languages, from Python and JavaScript to C++. Each has its own grammar, its own personality, its own vibe. It wasn't always this easy. The first monster computer, ENIAC, was the size of a room and weighed 30 tons. Programming it meant physically unplugging and replugging thousands of cables, like being a telephone switchboard operator for a very angry, very large robot. Then came punch cards, which was a marginal improvement. Now instead of rewiring a beast, you just had to spend your days giving it paper cuts. Then Fortran arrived in 1957 and changed the game. Scientists could write something that looked like a math formula and the computer would get it. This linguistic explosion has led to some weird places. There are things called esoteric languages, built not to be useful, but as jokes or art projects. There's a language called Chef, where the code has to look like a recipe. There's another called white space, which only reads spaces, tabs, and line breaks. It ignores everything you can actually see. It's the ultimate passive-aggressive programming language. And the craziest part, they can all theoretically do the same stuff as the real languages. You could run your bank on a programming language that looks like a Julia Child recipe, but you probably shouldn't. So here we are, drowning in technology. Our attention spans are shot, we skim everything, and our brains feel like they have too many tabs open. But the early computer pioneers had a much more optimistic vision. They saw computers not as replacements for our brains, but as amplifiers. Steve Jobs famously called the computer a bicycle for the mind, a tool to make our thinking faster, more powerful, and go further. And now we have AI. This is the next level. It can organize information in ways that are almost beyond our comprehension, creating complex maps of meaning. It's an incredibly powerful bicycle. But a bicycle can be used to win the Tour de France, or it can be used to drunkenly wobble into a hedge. The choice is ours. The magic of code, as Samuel Arbesman shows us, isn't in the ones and zeros. It's not in the syntax or the algorithms. The magic is that it's a fundamentally human endeavor. It's a language we invented to translate our wildest, most ambitious, and sometimes silliest ideas into a reality that machines can execute. It's a collaborative story we've been writing for decades, a new kind of art form, and the most powerful tool for inquiry we've ever built. It's a wonder of the modern world hiding in plain sight. So next time your app crashes, don't just get mad. Take a second to appreciate the magnificent, fragile, and utterly human cathedral of logic that just had a little hiccup.